Today I'm going to show you how I made the CNC4A control panel for the SX3 mill push button covers. This is the control panel as you've seen from the other videos. Here are the e-stops, the controller. It's in the matching blue now. There's mounts on the side. The switches have been fitted, push buttons, and as the holes were drilled into the steel, I needed a cover to A, protect them from any moisture, and B, to be able to easily identify which colours does what. So using the colour schemes again, green for start, red for stop, increase is yellow, decrease is orange, forward is white, reverse is blue, and tapping is the dark green. So originally I was going to use a membrane similar to the original one from the mill. Fits up there. That's just got a few holes in it, but the buttons actually protrude out, so the idea was scrapped. And as I designed the control panel further, this is what I come up with. Now originally for the membrane I was going to use the polymorphic plastic. Now can your 3D printer do this? Is it as flexible as that? I've got two materials here. This one is 1/10 thou thick, this is 5 thou thick. Can your 3D printer do that? 5 thou, fairly strong. Plus, how transparent are your 3D printed material? So it's excellent. So the idea was to make up a membrane over it, cut out sections and have them a different colour, and then attach it and then just push that. But I've just tried this colour scheme, see how it works, and I think it's worked out alright. So today I'm going to show you how to make the button covers the CNC4A way. These are the die parts for the polymorphic thermoplastic injection moulding of the button cover. This is the bottom die for the shaping the top of it. The taper area is highly polished. The two holes are for the injector pins above. Next are the split washers. The OD matches the ID of the bottom die. The ID is the diameter of the button cover neck. They are split so they can be removed. They were cut on the guillotine so there would be zero gap at the split. Each half is pot marked so pairs can be easily fitted. The thicknesses make up the width of the neck. The tube, which also matches the bottom die ID, is used to hold the split washers in place. The final piece is a top die which forms the shape of the inside of the button cover. It is also highly polished and the taper matches the PCB push button taper. The chamfer is what forms the spear locking lip to hold the cover in place. The OD of the top die fits into the ID of the tube. The M4 screw is used to force the plastic into position in the die assembly using a clamp. Pull the top die out and make it easy to handle when everything is hot. Fit the split washers to the bottom die so they cover the ejector holes and are layered 90 degrees to each other. Then push in the tube until all the split washers are sitting flat. Put the M4 screw all the way into the top die. Open the clamp so that the die assembly will have clearance. Have everything in easy reach for the next stage. Mix the die powder to give you the colours you want. If you have made up strips of the standard colours already, like these, you can mix small pieces to make other colours. For orange, it was 3 to 1, 3 yellow and 1 red, heated together and stretched like chewing gum, then ripped into small pieces, heated together again and stretched until they mixed to the correct colour. You can also have a marble look or a two-tone, etc. if you prefer. Cut off the pieces to make up the weight required. You can get an estimate of it from your SolidWorks model by using ABS as the material. Use an accurate digital scale. This one costs $7.95 and can measure 500 grams, half a kilo, to a 1/100th of a gram, that is 0.01 grams. This piece weighs 0.37 grams, or just over 1/3 of a gram. A little goes a long way. Heat up a container with some water and a polymorphic thermoplastic strips in the microwave until the water boils. Or boil up a kettle and pour the hot water over the strips in the container. White will become clear when it's hot enough. Form a ball and push it into the taper part of the bottom die. Make sure it is all below the surface of the split washer. Align the top die to the tube and push it in by hand. Slide the assembly into the opened clamp. Clamp it tight. This is injecting the plastic all over the die surface. This is the first foray into thermoplastic injection moulding. You can loosen it and twist the top die to smooth the top spear locking lip if required. Reclamp. Allow it to cool and pull out the top die. Put 2 pins in the bottom die injector holders. Push the moulded button cover out, taking the 3 split washers with it. Slide each half of the split washers apart. Trim off any flashing as required. Slit the spear locking lip into sections and remove the in-between one so that it can fold in when pushed into the buttonhole. There is no waste, just throw the offcuts back into the heating pot and form them into a strip for next time. There are no mistakes, just throw them into the pot as well. Experiment and refine to your heart's content. After the initial testing for sizing, I swapped the split washers for a ring plate that had 2 tapped M2.5 holes in it and drilled the matching 2.5mm holes opposite the injector holes in the bottom die. This stopped completely the top flashing. For the bottom flashing, I just raised the tube a millimetre and the excess just flowed into that and just pulled off. I also placed a new bottom die assembly into the hot water after I first pushed the plastic ball in, and as it stayed hotter for longer, the plastic injected better. It was a job well done. Thanks for watching.